Architerra is a tool that users can utilize to create 3D editable terrain objects in ArchiCAD from different input files. After the installation, Architerra appears in the Aptar Solutions menu. Here, we can find the Architerra palette, language, about, and registration options. First of all, it's important to activate the license, which works with an online key, just like other Aptar solutions. It means that while using it, the computer needs an active internet connection the whole time. If the connection is broken, the license will switch off and Architerra will not work.
Architerra doesn't have a demo version, so it either works or it doesn't. Of course, if somebody would like to try Architerra, it is possible to ask for a trial license, which works for 30 days with full functionality.
Activating the license is necessary with the received registration data. To start working with Architerra, we need tools. Clicking on the Show Architerra Palette option, all tools of Architerra will become available on the floating palette.
In this program version, a new palette is implemented, which is much more like ArchiCAD already. This palette is possible to dock to the left or right side of the ArchiCAD workspace. The old submenu, which appeared on the side of the main palette, is redesigned, and now it is possible to open down as in ArchiCAD Tools palette. Otherwise, this palette can be pulled wider or narrower.
This palette is divided into 4 groups of tools. First is an input, second is earth moving, third is street furnitures, and the last is parameters. Let's start with the first. In this group, there are some different input methods. I can import txt and dxf files, as well as shapefile formats. The next icon is to convert ArchiCAD mesh into the Architerra terrain. Without this, the simple mesh would not be usable for Architerra. Now I will create terrain for Architerra. There are 2 ways to create terrain, manually and from input files. I will start with the manual method. I have this small drawing, which is created with polylines or spline. Using these lines, I create the mesh element first. Select the mesh tool, click on the contour with the magic wand. Then select this mesh and click on the splines again with the magic wand. This creates ridges on the surface of the mesh. Let's check it in 3D. This mesh is still plain and only has some ridges. Back to the floor plan. I select one ridge, click on one point of it and select the Z value. Right now it is 2000 millimeters. And I apply this value for all points on this ridge. Click on OK. The result is immediately visible. It already looks like a terrain object. I select the other ridge, do the same thing, just with a different height value. Let's control it in 3D. Now I make this mesh usable for Architerra. I select it and click on the Convert tool. A window appears with some information. I click on Convert. This mesh is now ready for Architerra work. The second method to create mesh is using the input file. Let's start with the txt format. Click on the txt icon and select the file with the data. Click on Open. In the next window, some parameters are possible to set: units, coordinate format, decimal separator, etc. One more window appears with information. Click on OK. A lot of points are imported. To make terrain objects from these points, I use the special Outline tool. With this tool, I draw the contour of this terrain. This tool finds the points inside of this area. A filled area is created and I select it. Clicking on the Terrain tool, I convert it to the mesh object. Now, if I check it in 3D, I see there's a simple mesh object. The second import format is DXF. Click on the icon, select the DXF file and open it. A similar window appears as in the case of TXT. We can select layers and now the data is imported. I see a lot of points again, and now with the contour tool, I create a filled-in area. I can create it manually, but now I will use a rectangular tool. The add-on created a contour automatically. I select it and create the mesh object. In 3D, it is visible as an already more complex terrain object, which is a mesh. When the Architerra terrain is created, I can start to design other objects on this terrain, like a road.
So I presented to you how terrain can be created in Architerra. As a new feature, I show you now how to import and handle not only a single terrain. If I create terrain manually, I just have to draw a mesh and convert it to Architerra terrain. Earlier, it was not allowed, because Architerra could only use one terrain. If you have input files, like TXT or DXF, you can import 2 or more terrains. Let's see how. I click on Import TXT, select the input file, and import it. The process is the same as presented earlier. All points are imported. I select the outline tool and create the contour of the terrain, which is a polygon. When it's done, I click on the Create Terrain tool and the 3D terrain object is created. I now click on the Import DXF tool and import it the same way. All points of DXF are visible, and I select the Outline tool and click on OK. A message window appears and asks the user to choose what to do: substitute the existing polygon or keep it. If the user clicks on Keep, then the other polygon and the new terrain won't be created. But if the user clicks on Substitute, the previous polygon will be deleted and the new polygon is possible to draw. So, the contour of the second terrain is done. I can click on the Terrain tool and convert it to a terrain object. Now we have 2 terrains, and we can start to design other objects on this terrain, like a road, for example. The terrain does not show the level lines after the import, but it can be very important in cases where I want to do earthwork. For this, we have the Contour Lines tool. Just click on the tool. Settings window appears, where I can set some parameters, like equidistance. This value can be specified in any step, but the minimum value is 100 mm. I click on OK. And the result is visible on the floor plan representation. I switch to the 3D view and lines appear on the model too. Next, I will place a road. To create a road, I have to draw the polyline, which will be the track line of the road, and I will place the road on this. I can draw the polyline on the first terrain, and now I can draw the polyline on the second also. I select both polylines and click on the Road tool in the Architerra palette. If I want to create roads with a different parameter on two terrains, then I have to select the polylines one by one, not together. Now I will place the same road on both terrains. The settings window appears, where I can set some important parameters, like the width of the road, resolution of the curved parts, all slope values, the surface material of the road, and the surface of the slopes. Click on OK, and the road is created on the first and on the second terrain at the same time.
The ditch tool uses the same method as usually linear elements in Architerra. The ditch can be placed next to the road or independently of it. First, I will make a ditch without a road. Click on the Polyline tool in the Architerra palette and draw the path for the ditch. After this, I select the polyline and click on the Ditch tool icon. The Ditch tool we can find in the Architerra palette's Earth Moving section. The settings window appears. In this window, we can set all the parameters of the ditch. In the first line there are two checkboxes, attached to the road and user-defined path. If I place and select only the polyline, the add-on identifies it and automatically chooses the user-defined path option. But if the polyline and the road are selected together, the add-on will select the attached to the road option. It is common for the ditch to be built next to the road, but not always close to it. If this is the case, we should have the possibility to set this distance value. So the next parameter is the distance between the road and the ditch. Of course, this parameter is active only if we select the road and polyline together, so now it is inactive. Next settings option is the geometry of the ditch. Here there are two options. We can select a simple trapezoid section profile and its parameters, or we can select a custom section profile, which we can create with the profile manager of Archicad. Let's see this for first. The built-in simple profile has selectable parameters, the width of the top and bottom sides, the height, and the side angles. On the right side of the window, we can select Simple Ditch or Ditch with Lining. The simple ditch is just an excavated depression, that is, there is no surface covering it. The second one is a ditch with lining. If I choose it, I can specify the thickness value of the lining. Lower, all common parameters can be set, like the surface material, 2D and 3D contour pen colors, the resolution of the curved parts, and the layer. Here we can add a special ID for the curb element if necessary. So because I selected the prepared polyline, the add-on recognized the single ditch and selected the user-defined path option. Now I leave the default parameters of the simple profile and click on OK. The add-on places the simple ditch on the terrain surface. The ditch will be placed in accordance with the level of the terrain. I draw a second standalone polyline. I select it and click on the Ditch tool. I leave all parameters in default, but choose the Ditch with Lining option and click on OK. Now the same ditch is placed, only it has lining. The material of this lining is possible to choose or modify in the settings window of the ditch. Sometimes I have to modify the position of the placed ditch. I select the ditch, and with the editable hotspots I can change the position of it in the floor plan and of course also in 3D. Okay, next is the custom profile without road. As I said earlier, is the second option of the section profile of the ditch. I open the Profile Manager of Archicad from the Options menu and create a custom profile which I will apply as a ditch. I will not show how to make new section profiles in the Profile Manager because that should be a part of an Archicad course, but I will show you a previously prepared profile which I will use in Architerra. Here is the custom profile which I created earlier. I now close the Profile Manager and I select the polyline, then open the Ditch Settings window. Here I choose the second profile option, Profile from Profile Manager. All 2D and 3D values I can apply for this profile too, but the surface material depends on the surface definition in the Profile Manager. I click on OK, and the ditch with the custom profile is placed. The next sample is the ditch attached to the road. Click on the Polyline tool in the Architerra palette and draw the path for the ditch. This line should follow the edge of the road in a straight or curved shape as the road edge is going on, and should lie exactly on the points of the road. As a tip, if we make a copy of the track line of the road, we can have a correct polyline on the edge. I select the road element and the prepared polyline on the edge of the road. Then I click on the ditch tool icon. I choose the simple profile and I leave the default parameters with the lining option. When I click on OK, the add-on places the ditch next to the road at a distance which I defined in the settings window. This time it is 0, so the ditch is directly placed in line with the road. The ditch will always follow the level of the road, but it is possible to select and modify separately from the road. Let's check it in 3D. Of course, it's possible to select and modify the ditch in 3D too. If I'd like to change the parameters of the already placed ditch, I select it and open the settings window. I change one of the parameters, click on OK, and this modification is visible immediately. Let's see the custom profile next to the road. I open the Profile Manager of Archicad from the Options menu and create a custom profile which I will apply as a ditch. Here is the profile which I created earlier. I select the road and polyline on the edge of it and open the Ditch Settings window. Here I choose the second profile option, Profile from Profile Manager. I select the prepared profile from the list. I click on OK, and the custom profile ditch is placed. Many times we have to place the ditch on the edge of road elements in crossroads, where the ditch on the main road edge cannot go straight, as it should turn to the connected roads. In this case, the polyline does not have to be drawn in one continuous line. It can be several separate polylines. I draw the polyline on the main road on one and the other side of the crossroad, then a curved polyline on the polygon road, then the next polyline on the connected road side. First I select the main road with the associated polyline and click on the Ditch tool. Select the simple profile and click on OK to place the ditch. Then I select the polygon road with the curved line and repeating the same process, I place the curved ditch. I suggest to set a higher value for the resolution to get a more smooth curved element. Lastly, I select the connected road with the polyline and place the ditch. This way we can create a ditch in any place with any shape. Sometimes this process is possible to do in one operation if roads do not have big level differences. The gradient tool is a new feature in Architerra. This tool allows users to measure the slope between two selected points on the terrain surface in either degrees or percentages. Click on the gradient tool icon and a settings window appears. In this window, I can set the parameters in the text field: size, pen color, font style. Below this, the size and the pen color of the arrow is possible to set. On the right side of the window, I can choose in which unit I'd like to see the measured value. As usual, I can set the ID of this object and the layer. Click on OK and the tool is ready to measure the slope. With the first click, I define the start point of the arrow, and with the second, I finish the operation. When I click a second time, the arrow element appears between the two selected points, and on the line of this arrow, a number shows the measured value. The indicated value shows a negative result if the surface slopes downwards, and shows a positive result if the surface rises. If the text field is not in the right position, I can select the arrow element, and with the purple editable hotspot, I can move the number field to any other position. Selecting the arrow, I can open the settings window and change the unit of the value. When the height of one of the two measured points is changed, the tool recognizes it and will change the indicated value accordingly. This gradient tool is possible to use in any places on the terrain surface and at any time. Next is a railway. As we did in the case of the roads, we draw a polyline that defines the track of the railway. I select this polyline and then click on the railway tool. The settings window is similar to the previous one. Click on OK and the railway will be placed. Here it is. Go to the 3D view to see the result. It looks pretty good, like a real railway. When the road or railway is placed, a slope is created at the same time, which is visible on the floor plan and with different colors in 3D. Next, I will create a plateau. The method is very similar to the road, but here I don't draw a polyline, but a fill, which defines the area of the plateau. I place the fill, select it, and click on the Plateau tool. The settings window is similar to the previous ones. Click on OK and the plateau is done. Go to the 3D view and the plateau is visible on the model. I can place schematic houses. The contour of houses is defined with the polygon. I select it and click on the House tool. The settings window contains some parameters, and clicking on OK places the house. In the third group of tools, there are some interesting things, like trees. Here I can set the complexity of trees with many parameters. Clicking on the surface of the terrain, I place some of them. In 3D we see two interesting things. First, the add-on places trees always on the surface, detecting the height of points where I click. The second is that all placed trees are different shapes, and the result is a more lifelike picture.
On the bottom of the palette is the coordinate box. With the pipette, I can click on the surface of a terrain in any point and see all coordinates of this point in the X, Y, and Z fields. During the work we can do many changes in the terrain shape and surface, and it is not always visible immediately. To update the terrain, I can click on the double circular arrow icon and refresh it. If there were any changes done in the terrain, this icon switches to the red color with an exclamation mark, so I can see that the terrain should be updated for correct representation. When there are no changes, this icon is simply black without any warning signs.
Finally, I'd like to show you some pictures. This terrain and its objects were created with Architerra and rendered with Twinmotion. If you have any questions, please send it to us. Thank you for your attention.